Okay. Hello, everyone. My name is Zahraa Alden. I am from the University of Altinbas. I'm PhD candidate at the University of Altinbas. I'm actually a lecturer university at University of Karbala in Iraq. I'm here to do my presentation about my paper, optimizing deep learning model for osteoporosis detection, which is a case study on knee X-rays images using transfer learning. Here on our agenda, we have introduction. We're going to talk about some of the research have done on using machine learning and medical image processing, and which of the machine learning models or techniques that have been used during this paper. And then we'll go to the related work and research gap and how our methodology had been able to overcome the research gap that exists in using machine learning to detect osteoporosis. And then we'll discuss the results and conclusion. As we know, there are many challenges in human diagnosis for a manual diagnosis because anything can go wrong because of the memory and perception, particularly for, sorry, there is something wrong with my screen. I can't see it. Yeah. Particularly for such subtle disease such osteoporosis, but using deep learning algorithm or machine learning in general can reduce the dependencies on human processing of medical images and reduce time managing between these between the cases. The importance of medical images can be very important in visualizing and making sense of the structure and function within the human body. As we know, some techniques that can help in predict and diagnose health condition, MRI, CTs, and X-rays. And there are many advancements in healthcare, including image processing and the diagnosis and treatment planning to the study of disease mechanism and therapy evaluation. Using machine learning can become more accurate and efficient for the diagnosis and treatment planning for the patient. Machine learning had been used in wider application and image analysis as well in different industrial application, not just in medical application. If we want to discuss about medical image processing, we can discuss the different mechanisms that been used for analyzing the osteoporosis images, X-rays, CT scans. There are many various medical image techniques that been used and employed to assess the bone density and structure, pinpointing the areas that reduce bone density and that could indicate osteoporosis or normal cases. By measuring bone density in body regions like the knee, spine, and hip, there can be very valuable data that can be extracted to monitor changes over time and provide insights using references. These data can aid in health professionals in determining the severity of osteoporosis or normal patient and start planning for the treatment or what are the strategies for treatment. Besides diagnosis and monitoring, medical image pre-processing can also evaluate the efficiency of osteoporosis treatments, such as which medication should be used, which lifestyle modifications should be altered for the sake of changes for the bone density over time. There are many medical image operations that have been done on the some of them have been used in this particular article. These medical operations can help the machine learning and deep learning techniques to better understand the features that can extract important features from the medical images, such as X-rays and CT scans or MRI. These include registration of image that is iterative procedures that will understand or seek the optimal mathematical transformation model for aligning two-dimension or three-dimension image data. Segmentation of image, The fundamental purpose is to organize pixels into distinct image areas, for instance, areas representing certain surface objects or natural elements of objects. All automated segmentation techniques minimize human intervention and reduce inconsistency. If we want to discuss about smoothing of the images, which is like understanding what are the neighborhood averaging, this is the most important methodology, or operation that we use for medical images. These replace each pixel with average value of the pixels around it that reduce the noises in the images. The next point is to denoising the images, which is important to process for analyzing and extraction of useful information. Since we are using MRI or CT scans or X-rays, they are due to many noises that can be during the capture of these medical images. These noises can call poison noises that obscures the features of diagnosis. Thus, we need to use denoising of the imaging to be able to use it more efficiently in machine learning models. Data documentation is also important. It enhances the diversity through augmentation techniques and strategies such as rotation, zooming, or shearing of the image to help improving the model robustness and generalization. Integrating image into healthcare can have a huge implication to move from manual prediction of diseases to automatic prediction, enable automated diagnosis tools that mean higher quality and speed for diagnosis, especially for resource constrained settings. Based on our work, our model is using mobile net V2 method or technique, which is a deep learning based on CNN medical image using medical image analysis that will analyze X-ray images to identify and predict osteoporosis. The model perform better because we have used integrated weight loss and schedule learning rates. The integration of these tools in clinical practice will facilitate the process of early detection, enabling personalized treatment planning and monitoring the lifestyle of patient, and then ensure the effectiveness of monitoring the cause of disease. Machine learning and deep learning have been widely used in medical area, in healthcare sector. Some methods have been used neural network to acquire significant data or training techniques to evaluate and manipulate the medical images, while convolutional neural networks continue to be one of the best performance techniques. Many researchers have carried out certain pre-processing to find the key region and correlate image sequences. Most cases for us, during our research, we find that deep learning methods have been widely used to interpret X-rays, CT scans. The outcome can be compared to other models and other methods and have higher accuracy models. Such algorithm can be designed to recognize patterns in images that might indicate specific disease or medical conditions. This is the literature research have been done using machine learning or deep learning for medical image analysis. This had been done using Web of Science database. We can see from 2018 to 2040, many cases had been increased for the total number of areas or research has been done. There are more in 2024, but since the our work had been writing for this article was the early of 2024, so you can see the number of papers are smaller, but it highlights the importance of, we can see from 2023 that number of research papers that was published in Web of Science using deep learning had increased over time. And we can see from the structure here, we can see that the number of pages, number of articles increased over time to a total of over 2,800 papers. There are many challenges that includes working on such important aspects for medical image analysis, which includes data security, generalization, or noise nature of medical image, as we said earlier. Some of these challenges we were able to overcome during our process for the medical image. Because we are collecting large-scale labeled database from medical image, so there are many ethical consideration, many intensive process for expert notion over limited availability of data. So if we don't have enough or sufficient data, the deep learning model can struggle to analyze or reduce the performance, and therefore our model will not be important in the research area. For generalizability, we can see that deep learning models are not trained on diverse database, which this can be the lack of generalizability can be led to the mid-diagnosis, or especially if the models are applied to specific region, or population. The noise nature of medical images, as I stated earlier, because we are depending on machines of X-rays, CT scans, and MRI, can collect many noises, such as poison noises. This can be very challenges for the deep learning methods to overcome, or it can very be challenges for the researchers as well to overcome these challenges to provide a better model for the diagnosis of our medical image. Some of the problem statement that we have encouraged or during our research for using machine learning or deep learning in specific for medical image, we have many research gaps, such as the complexity of medical image, because the many X-rays, as I see before, my colleague was explaining her work. Many of the challenges we have faced as a researchers, that the outcome of the analysis of X-rays and CT scans can be very detail rich. We cannot, some of them cannot explain it without having the either a very trained model that can express and can interpret the results we have come from using these methods or using these machine learning techniques. So the need for further explanation to overcome the problems that we have during the medical image processing. Other challenges can be the bias or errors in training data. This can very affect the model accuracy, as you can see, because the inconsistency or the incomplete data set can lead to models that fails to generalize or provide incorrect prediction. Since we are dealing with healthcare data, so we need to collect more methods often reflect specific population. And this, because we are using a small region or a small population, this can be a bias model. So many research have to done using machine learning or deep learning. We have to use more population to incorporate more population, more region. Other problem, we have transparency or interoperability, as we stated before. Since we are using with deep learning is known as a black box. The results of these methods, or the results of deep learning method, some of the treatments, the results we cannot express, or we cannot interpret, we cannot understand, since we are not medical professional as well. So we need more incorporation between the scientists and the medical sector, medical professionals, to we can understand the result more more clearly. So this is can be challenging to detect the disease or incorrect diagnosis of some of the diseases. And since we are using deep learning models or machine learning in general, there is no universal accepted method for assessing the effectiveness of these models. The lack of standardized evaluation from framework make it difficult to compare algorithm and identifying best practices. Our methodology here will be in two parts, selecting the best image acquisition method and then selecting the best deep learning techniques. Since we are using X-ray imaging, since we are using medical cases here to analyze in deep learning method, there are three more important best image acquisition method, which is the DXA or CT scans or MRI. DXA is often regarded as the preferred method for osteoporosis diagnosis because it's for its speed, for its cost effectiveness. It's widely used in many medical centers and hospitals in many areas, in whether they are poor areas or rich areas. So DXA is widely used. Second, we have the CT scans. Since it's been used for many cases, many medical cases, but it is more costly than DXA, and it involves many radiation exposure, and many hospitals would rather use DXA than CT scans or MRI. Since CT scans can be used for detecting osteoporosis, but it can be challenges. It needs more time. It needs more radiation exposure to the patient. So most cases they use DXA. MRI as well, since it's used more radiation exposure, it is more about tissue than about the bone itself. So it cannot be used. It's also expensive and time consuming. So more cases use DXA or CT scans. Many patients would rather use DXA as well because it's they are frightened of using CT scans or MRI because of the machine itself sounds very scary for most patients. So they use DXA in general. So in this study, we use DXA as an option for osteoporosis screening. And even though we have CT and MRI are more important, but we are more important in detecting early stage of osteoporosis, but we use DXA as it's widely used in many medical centers for our model to be used in different medical centers. So we need to use DXA. And then we go to selecting the best deep learning techniques. Since we have many areas of using either CNN or RNN or GNN. Many cases used CNN as it's more adaptable, and it's more cases that we use CNN for medical image. It's very highly recommended from different researchers. It can learn patterns within images to make a prediction more about the content. RN is also amazing in working for processing data, but it is only for it's highly accurate in using time series or text. But when using imaging for RNN, it can be challenges, so it can take over time and can identify some signs of osteoporosis, but mainly, as we can see here, from doing CT scan, from doing research, we can see that CNN has been widely used over time. In 2022, we can say the number of higher number of articles researchers have recommend using CNN. That's what we use the CNN model. Our model will incorporate transfer learning as it's frequently accomplished used pre-trained model. And these models are trained on big data sets. So we can use it as our base model for our developed model. And then from that, we can incorporate our new data sets into this new deep learning model, which involved using mobile nets and CNN model. We can see here in 2023, the number of cases or number of research had been using transfer learning increased from 2018 to double it in 2023. The key advantage of using this approach is by for transfer learning is a pre-trained model like MobileNet we used here in our model that solves data scarcity and computational problems associating with medical image. And MobileNet version 2 model is composed of depth-wise separable convolutional and is pre-trained on a large data set such as image.net. So MobileNet version 2 or MobileNet v2 technique prioritizes reducing latency while enabling small networks to operate efficiently with input of any size. It designs leverage the ReLU activation layer, activation function for each layer, and then combined with batch normalization and deliver excellent performance. Thus, we used transfer learning for our model using MobileNet v2 as it's a lightweight model for our case here. Here are some related work that been using transfer learning and deep learning for medical image. So there's a research in 2023 had been using transfer learning for image for analyzing breast cancer and the high accuracy in encounter of 91. The model shows their limitation because it relies on only one data set. So they specify that their limitation includes time consuming for training of the model. Another systematic review by Kotby in 2024 shows the performance on the powerfulness of AI in healthcare sector. It shows the research gap and future work to enhance the quality of data, including generalizability of the model and technique issue. Other research in 2021 by Nigon developed a model based on CNN algorithm. Their model also based on X-ray images, but their limitation was their data set since it didn't cover enough data for both gender equality, and thus we have a biased model. We have another research done in 2022 that discussed this was I think a comparative study that does discussing various machine learning approaches to using detect osteoporosis. Of their limitation was number of hidden layers is randomly chosen, which affect the efficiency of their models, and the algorithm was not effectively modify the weight of RNN model to prevent false learning process. They didn't use, as we discussed earlier, they didn't use CNN. Other research areas that have been done using MRI or CT scans, it shows how important this methodology are in providing important data about the bone structure. Another research used CNN model to diagnose osteoporosis using MRI images as well. But the limitation was stated that the diversity of MRI system by converting them to two-dimensional area where many features were lost. Another literature review done by Mr. He in 2022, sorry, emphasizes the advantage of using transfer learning in medical image analysis. Also have data scarcity problem on saving time and hardware resource. Another transfer learning research on breast cancer illustrates the benefit of pre-processing approach to increase the accuracy of our model, of their model. to overcome the challenges acquiring from large data set to be trained in the data in the model. Here in our work, the data set is publicly known in the Kaggle database. It has about 372 cases for normal and osteoporosis X-ray images. It was pre-processed and analyzed to extract only the useful images or useful cases for the image classification. The data set was split into a training and validation set where only 460 images belonging to two classes for training and 92 images belong to classes for validation, and then two classes for these two classes were osteoporosis and normal classes. Sorry. We can see the images for normal osteoporosis. As you can see from clearly, the osteoporosis have very low bone mass. Whereas normal, we can see it has a normal imaging, normal bone density. Our proposed mobile net CNN model is a hybrid model that uses both mobile net and the CNN model. We can see that we already have discussed that mobile VNet is highly important because of its lightweight and the structure of the mobile net V2. We have used mobile net CNN model to designed by using class weight and learning scheduling. So there were two models that were proposed here in our work and then compare the results of the two models. Class weight is because we are dealing with imbalanced data sets. Some classes have maybe fewer samples than the other. The class weight is very helpful. Learning schedule is a strategy for adjusting the learning rate during the training of the model that can help transfer learning model to perform better, especially when dealing with imbalanced data set. So this be by fine-tuning the pre-trained model. Also, another techniques used in this model, in our proposed model, which is the image augmentation. As we say, it is very important to increase the size and diversity of our data sets to increase the robustness of variation of different cases that can be included in our model to overcome some overfitting or improve the model generalization. Here we can say the typical construction of the mobile VNet model. It have the first layer have the pre-processing layer that is important for normalization the input data, resizing the images. It ensures the data consistency to improve the training process. Then we go to the next layer is pre-trained convolutional based, which is it's kind of one of the best layers in mobile nets because it acts as a feature extractor to more leveraging the transfer learning. And this actually utilizes a pre-trained large data sets on ImageNet, for example, to extract relevant features like the edges, contours, and extra. This will reduce the time training and minimize the need for a large data set, so it can be a robust feature extractor and representation for our model. And then the next layer is the global average pooling, that this reduces the dimensionality of feature maps by computing the average of each feature map channel. And then we have the classification head that have the different layer, dense layer and dropout layer between each layer. The dense layer have 512 units that can apply for nonlinear transformation. The ReLO, which is an activation layer that introduce nonlinearity that ensure the model can learn complex data. And we can see here there is between each layer there is a dropout layer which to the dropout layer, to regularization technique to regularize our model by dropping 30% of the features from the of the neurons during training. And the last layer here is dense, which have scene unit to corresponds to the number of units that we are having in this model. And then the last one is using not reload, but using softmax activation layer that is suitable for converts the logits to probability for the classes that been used for in multi-class cases. So we integrate this mobile VNet model in our model by using mobile VNet and then using our CNN model. You can see here the mobile VNet, mobile net V2 has a number of layers, the same layers that been used in its typical architecture. We used here global, after using mobile net, we used a global average Boolean 2-dimension. This is the input shape represents to the extracted feature map, which is 1028 map, a feature from the mobile VNet. And this feature map contains rich spatial information extracted from this model. The global average Boolean 2-dimension is very important as it's summarizing the feature map of the spatial information for just a single value or 2-dimension values. They focus more on the importance of the features than their location. And then we have several dense layers that you can see by each one, further refining the learning features and reducing the number of dimensionality from one layer to another layer until we get to the last layer that reduces to just the probability of using other of output class 0 or 1 to represent normal or osteoporosis. By using these architects, the model combines the benefits of transfer learning, which is a robust feature extraction, with lightweight and efficient classification heads, and then using CNN model to further refine the models and extract it to analyze the X-ray images. Here are the results. We can say they have developed two models, one with class weight but no learning rate schedule, and the other one have class weight and learning schedule. We can see the precision recall and text accuracy for both models are very high, but we can say that the test accuracy for the second model that uses class weight and learning rate has very high accuracy. So we can say that model 2 have high accuracy, which is 96%, and high F1 scores is 84% comparing to the other model. Even though model 2 have a good balance in precision and recall, model 2 that uses class weight and reschedule considered the best model to be used for the classification and analysis of medical image to predict osteoporosis, as it has the first and higher accuracy. If we want to compare our work to other research that uses the medical data and uses CNN model or mobile net transfer learning, we can say that our model had overcome their accuracy. As we can see that there is, for example, a study conducted by Fradi in 2022, their accuracy was only 87%, even though they used mobile net and as a basis for their CNN model. And Abdel Baki in 2021 also used mobile VNet, mobile net V2 model as a basis within the 3-layer of CNN model, same as our model. Their accuracy was 90% for their proposed model. Another accuracy that was to identify or to analyze oral histopathological images to malign or benign lesion have higher accuracy of 95%, and they are proposed model that use CNN model achieved accuracy of 93%. Other model that used for analyzes images of the patient eye, frontal nerve fiber layers. It have an accuracy of 86 for the left eye and 90 for the right eye. This model conducted in 2020 using transfer learning to detect glaucoma in Latino population. So their model also have a bias since it uses only the Latino population. Other model use deep learning model to classify chest CT scans to detect lung malignancies. Their transfer learning model had accuracy of 85% or 86%. There are many challenges in osteoporosis detection, as we can say that most models depend on bone density and the structure of the bone. That for that, it requires detailed and precise models for image analysis. Many of these challenges we have already expressed as the bias in training data, the risk for overfitting, limited data since there is no large data set that are noted and explained by medical professionals. So when we use of our model, we need more interpretation for our deep learning model results from the for the medical professional to be able to use it in their medical center. For our model advancements, since we are using class weight and learning rate, it had effectively balanced the data set representation and avoid overfitting to enhance coverages. Used also the using of image augmentation, improve the model robustness and generalization by enriching the data set to have a large data set in our model. Our impact, the model demonstrates a breakthrough in automated osteoporosis detection to facilitate early detection, enabling timely intervention to prevent fracture and other disease for the patient to progresses. Advanced precision medicine by providing a scalable, cost-effective diagnosis tool, and also promote the adoption of transfer learning in medical image to providing effectiveness of developing reliable and efficient diagnosis model. For further direction, we can expand the dataset to include diverse population, incorporate advanced explanation method to bridge the gap between AI. Sorry. Sorry, I can't understand you. Someone's trying to talk to me. Okay, we'll continue.
Okay, it's okay.
Yeah, no problem. Future direction can also explore integration with the clinical workflow for real-time osteoporosis detection. Actually, this is my current work of to further working on this model to develop a real-time osteoporosis detection tool. So hopefully it will come up with a good result to participate in your next conference in Denmark, inshallah. This combination of robust results, impactful methodology, and practical implication to underscore the potential of AI-driven solution in transformation osteoporosis diagnosis. Our key contribution, including development of novel model, since our model achieved high accuracy and high F1 score. So using mobile VNets had been very effective and capable of handling data accuracy, highlighting its potential for clinical application. Addressing key challenges, since most models have addressed the key challenges of imbalance data sets. We used class weight, and other research have a problem with the time training. We used learning rate scheduler. We also have a medical impact since this model can demonstrate the capability of automated osteoporosis detection for early and efficient diagnosis in clinical settings, centers, and hospitals. Also, this is a benchmark and comparison of our study to other models that use the same transfer learning with CNN model to emphasize the performance advantage in our term of accuracy and robustness. Also, focus on lightweight architecture by using MobileNet v2 to propose a practical solution for resource-constrained healthcare environments such as osteoporosis. Thank you so much, everyone, for listening to me, and I'm ready for any questions you have.